All right, so I am recording. This will be uploaded to YouTube later today or tomorrow. If you have questions, just either unmute or just answer them in the chat. Um, if I don't have anyone stopping me, I'm just going to do basically the same thing I did earlier today. So if you don't want me to do that, stop me now because I see a lot of the same names. But I'm going to start off with just talking about flow rate because those are the newer questions. And if you have other questions, just let me know. All right, bear with me if you can still hear me because my computer froze. So we'll see. Yep. Sorry about that. My computer froze. All right. So flow rates, as a reminder, when we talk about flow rates, flow rate just means that we have a volume over time. Usually the flow rate is milliliters per hour. Sometimes it's milliliters per minute. Sometimes it's drops per minute. Okay. But if a question asks you to calculate the flow rate would be milliliters per hour. Okay. So for this example here, we have a patient is receiving 375 milliliters Ringer's lactate over 3 hours. What would we set the infusion rate to? So all I'm going to do is I'm going to take the volume, 375 milliliters, over time, 3 hours, and I'm going to reduce that to 125 milliliter per hour. So because you're here and you want to see some new type questions, I'm just going to copy and paste this, and then we're just going to make a similar question. I'm just going to use different variables. So let's just say the patient is to receive 500 milliliters over 4 hours. What would you set the infusion rate to? So since you've looked at this before and as practice, go ahead and what would you put for your answer if it's 500 milliliters over 4 hours? What would the flow rate be in milliliters per hour? And just put your answer in the chat. You can do it as a direct message if you are not 100% certain of your answer, and then I will also work through it. So go ahead and see what you get. All right, so you should have gotten 125 milliliters per hour, but just as a review, we have 500 milliliters infusing over 4 hours, and we're going to reduce that by just taking 500 divided by 4, plug that into your calculator, and you're going to get 125 milliliters per hour. All right. I'm going to do another one of these. Where we're going to change up a couple variables here. Let's say it's 250 milliliters and it's 75 milliliters per hour. So this should be interesting because it should give us a time that doesn't work out, and I'll show you what I mean by that and how to get it right. So this is an example. You probably won't see a question like this. I'll do this first just to show you what it would look like as a problematic type of question. But I'm going to follow the same format I did up here, where I'm going to take the volume, the total what I have available, the 250 milliliters, and I'm going to divide it by 75. And then that's going to give me how many hours it's going to infuse at. So if I'm setting this up, my total volume is 250 milliliters. And it's flowing out at 75 milliliters per hour, and I want to know how many hours it's going to infuse or how long it's going to take. So this is actually going to be something that we can get a calculation off of. So we can actually get down to the minutes here in just a second. So if you do this just by doing 250 divided by 75, you're going to get 3.3 repeating minutes or hours, which is probably fine to answer this. But if you wanted to do this more specifically, I'm going to show you this. You're going to hate this, but it's a good practice for just kind of figuring out how to do some of these more things that you might see with ATI and NCLEX later on. So if you ever get something where it's like they want you to be more specific, they want to know how many minutes, like get it down to the as specific as possible. One of the things you want to do is convert the minute or the hours to minutes. So what you would do is you would take your 250 milliliters, and I would say instead of 1 hour, it's 60 minutes, and then 75 milliliters. And then I'm going to find out what the total minute calculation is. So 250 times 60 divided by 75. It's going to give me 200 minutes. So then you can sit there and you can rationalize through this. And you can say, like, okay, well, 1 hour is 60 minutes, 2 hours is 120 minutes, 3 hours is 180 minutes, right? So if 3 hours is 180 minutes, so I'm just going to say like minus 180. Again, you're not going to see a question like this. This is just for, we'll call it fun, but I don't know that you're having fun with it. Okay. So if I want to be very specific, how long this is going to run is actually going to be 3 hours, 20 minutes. Again, you're not going to need to worry about how to do that. I just wanted you to see how you would do a question like that, just in case you come up across one like you're doing ATI practice problems and it shows up. It might be helpful to know how to do that. All right. Let's look at some of the drop factor questions. So a lot of times they'll give you the drop factor on the label, but if it doesn't, it'll be listed in the question itself. On the label, you're just looking for the drops per milliliter. So here it's 15 drops per milliliter. Sometimes it'll say 5, sometimes it'll say 10, sometimes it'll say 20. It's just whatever it says, that's what you use for your drop factor. In order to calculate drop factor, you just need your flow rate times your drop factor, and that'll give you your drop rate. If it gives it to you, your flow rate in minutes, like in this example, they tell you 75 milliliters in 25 minutes, don't convert minutes to hours. Leave it as minutes. So 75 milliliters, 25 minutes times your drop factor of 15. And that's how we get an answer of, for this one, 45 drops per minute. I also did an additional problem.
But before you move on, what was the
Yeah.
formula that you said for that one?
It's flow rate times drop factor.
Oh, right there. That's where you wrote it. Okay.
No, you're fine. Thank you for asking. And that formula is also listed in the beginning of the it'll say like helpful, oh, where are they? Helpful questions. So right here it's listed as well. Flow rate times drop factor equals the drop rate. So it's listed in there for the helpful equations as well. All right. So, and then this is a newer question that I put in today. It's just, I changed some things up. I gave you the drop factor. I told you that it was 375 in 2 hours. And then I asked you to calculate the flow rate. And then what we did differently with this one was that there was a, it came out to 62.5. And we talked about earlier, we can't give somebody a partial drop. You can only give them a full drop. And so you need to round to the nearest whole drop to do that. So that's always the caveat when it comes to your rounding rules, is that if we're talking about drops, you round to the nearest whole drop. Same thing with like capsules. You can't give somebody a partial capsule. They get a whole capsule. So you would round to the nearest whole. So if it's like 1.1 capsule, they're getting 1 capsule. If it's 1.5 capsules, technically you're going to give them 2. But it shouldn't end like that. All right. And then the last, like I said, the newer thing. So these are, you should have seen these last semester. These are the original reconstitution type questions where you have an order, and then it gives you different strengths. Then it tells you to use the strongest concentration. The strongest concentration for here is 20. Here it tells you to choose the strongest concentration. And then the strongest concentration is actually going to be the 1 million. The 250 and the 500,000 units per milliliter are the other types of strengths, but they're less potent. And so you're choosing the strongest concentration because the question tells you to choose the strongest concentration. What I think is a better question, one you might see later on, is this newer one that I put in, which is the reconstitution label that they use at like Boyce, North, and South. We just haven't really used them too much at Allegheny campus, but you might see it creep up on future tests, which is why I'm letting you know about it. And the trick to this is just finding where it is on the label. And part of the challenge is knowing that you have to search the label for the information, the reconstitution. So a couple things. When you're doing something like dilantin, so like if I go back up to early on in the question set, it says you're to administer 250 milligrams of dilantin. How many teaspoons will you give if it is labeled as shown below? So this one is asking how many teaspoons. But we look at our label and it says 125 milligrams per 5 ml. So we know how much milligrams per volume in order to calculate how many milliliters, or in this instance, teaspoons, to administer to our client or our patient. When we come down to the ANSEF question here, you'll notice that the label does not say anything about milligrams per milliliter. That's your clue that you're dealing with one of these tricky-ish type of reconstitutions, because everything else is going to seem the same. 0.375 grams intramuscular every 6 hours. It's a typical type of question, typical type of order. But the difference is now we have to look at the side label to see what is going on and how to answer this question. Okay. And so when we look at the side label, what we're looking for is what I have circled here. We're looking for that 225 milligrams per milliliter, because that is the strength after it's been mixed with the sterile water. And then that's the information we're going to use as our available and for our calculation. So I would convert 0.375 grams to milligrams, divide by the 225, multiply by the 1, and then I'll get a rounded answer of 1.7 milliliters. So that's kind of like a brief recap of what I covered in the first section. You have a little bit of time if you want to look through and see if there's any questions that you'd like to see worked through. Just let me know what you need help with, and we'll look at them together.
Okay, I have a question for you.
All right, go ahead.
Um, all right, so on the helpful equations, you have those three formulas plus dimensional analysis. Can dimensional analysis replace those three formulas?
Correct. Yeah. If you can master dimensional analysis, and even not master, but if you utilize it, you don't need any of these formulas. You could just use dimensional analysis to come to the answers that you're looking for, assuming you know how to use it. So I usually try and show you dimensional analysis, but sometimes it's easier to remember like a formula or an equation, that you can use in certain situations. But personally, when I'm doing these problems, I'm just setting them up using dimensional analysis.
Yeah, I think that's what I prefer.
Yeah. All I'm doing is like, so even when I say flow rate times drop factor, that's just telling you, it's simplifying the dimensional analysis. It's milliliters per hour, milliliters per minute times drops per milliliter. Cancel out milliliters, you're left with drops per minute or drops per hour. If it's drops per hour, you convert hours to minutes. If it's in minutes, then you're done. And it's essentially just doing dimensional analysis. I just gave it a name.
Thank you.
Yeah, you're welcome. Yeah, so if you do dimensional analysis and you're getting all these questions right, you're doing everything right. There's no one way that's the best way. I mean, I will argue that anytime we're doing anything with like whether it's nursing or like farm tech or pharmacy like calculations, dimensional analysis is like my go-to, but it's, lots of people have lots of ways that they answer these questions. Yeah, again, just take a look over the practice test. If there's anything that you want to see work through, even if it's, you know, you think it's simple, just let me know and I'll work through it with you.
Printout, it's for my printout, it's for every 125 milliliters of urine output, replaced with 40 milliliters of H2O via PEG tube every 4 hours. And then it asks you the question just so you can find it on yours.
Thanks. Sorry. I said, go ahead and walk me through, how would you answer this question?
All right. Are you talking to me or to anybody?
Anybody, but you asked the question, so if you wanted to do it, that's fine.
Okay, I might be stupid here, but
No, let's do it.
I'm
This
I'm
is where we
gonna
find out. Yeah.
yes. To me, when I look at this, it's a panic situation because there's so much information in it. But to break it down, I want to know what I'm looking for, and it's fluid fluid replacement volume in milliliters. So right away, I want to find what something in there that has milliliters, and there's two. Um,
There's three.
Milliliters, let's see, is there, yes, there's three. So that's when panic sets in.
Okay, fair enough. So this is where I deviate a little bit from traditional dimensional analysis, even though I'm going to set it up pretty much the same way. But I want to explain my rationale with this. So you have to separate what each milliliter represents. Okay. So the 125 milliliter that's here is urine output or expected urine output. This 500 milliliters is also urine output. So you have 2 milliliter outputs, and then you have one listed 40 milliliter input or replacement. Okay. So we're drinking and we're peeing. So what we're trying to figure out is if I am, for every 125 milliliters lost, I need to replace with 40, what would that be with 500? So there's a couple ways that this can be done. Um, the the first place that my mind went when I first looked at a question like this, and mind you, I don't make these questions up. They just come from like the textbooks and stuff like that. So I'm not like, it's not like I came up with this and I'm like, haha, I'm gonna get you guys. It's just how it was written. So, anyways, I thought of a ratio. I thought, okay, if I know how much, like theoretical output and then actual output, then I should be able to calculate my theoretical replacement with my actual replacement by doing a ratio proportion sort of setup. Then I took that information and I just turned it into a dimensional analysis type formula. And so what I do, or dimensional analysis, and what I do is I start off with my actual, what I actually voided. So my actual output was 500 milliliters. I actually voided 500 milliliters. And then I'm going to put that over the expected output of 125 milliliters. Okay. So what I'm trying to do is find out what is that relationship. So if you were to reduce that down, it would be 4. The number would be 4. You'd cancel out milliliters, but it would be 4. And then just so I think this will also help you out, it helps me out too. We can say this is the milliliters out. Milliliters out. Then I'm going to multiply by my milliliters in. That's the 40. So I guess what I'm doing here technically, if we're going to do this true dimensional analysis, is I'm looking at this as 40 mil in for every 125 mil out. So that's my conversion, right? That's my conversion factor, is the in versus the out. And so if I'm doing this in a true dimensional analysis setup, then technically what I'd want to do is say the 40 milliliters in, and then that's where I would put the 125 milliliters out. I'm doing this for you because I know you like to do the dimensional analysis, and I'm trying to show you how I'm differentiating between the different types of milliliters. One is P, one is water, right? So I know what my total out is, and then I'm going to use the 40 over 125 as my conversion factor. And then when you do that, you'll get 160 milliliters in as your replacement volume. And I apologize if I went into the weeds and made that more confusing than it needed to be, but hopefully that helps.
I think the dimensional analysis was way easier than that ratio. Not the ratio, the first way you started it, with
Right.
the 2 outs and then just reducing it. Yeah, no, this is much better for me.
Okay. Good. Yeah. And if you can set this up, as the hard part is going to be differentiating which is the output and then which is the input. But if you can do this, and I know that you can, because I know you can do the dimensional analysis, you'll be fine.
Um, so it wants to know how many capsules you give. So I'm assuming it wants to know how many capsules in a day, or does it want to know how many capsules in a serving?
Good question. So by default, it's per serving. So, or per dose.
I would have gotten that wrong then. Okay,
Yeah.
thanks.
So usually on the test, it should say how many capsules per day or per dose, but per day, they're going to be very specific and they're going to ask you per day. But if it doesn't say per day, it's per dose.
So that's 2 a day. I mean, 2 per serving and 4 a day.
You got it. And this would be the same thing. Like, it doesn't tell you, it doesn't say per day or per dose. It just says you will give how many tablets. but because it only tells you to give 2.5 milligrams, you don't know how often he's getting the Valium per day. You just know that the order is 2.5 milligrams, so it's probably just for the one dose. But he's probably going to end up taking it again. Maybe it's as needed every so many hours, but yeah.
Amoxicillin one with the cup. So it's number 10, the amoxicillin one with the cup. You have amoxicillin at 0.375 grams by mouth every 6 hours. All right. That's the order. You have amoxicillin suspension, 125 milligrams for every 5 milliliters. So it wants to know how many milliliters per dose. So we're going to have to convert grams and milligrams or grams to milligrams, correct? And then go from there.
That is correct. The other secret to these types of questions, when it's a cup, it has to be precise. So the answer is going to be on the cup.
All right. Okay, so I wrote 5 milliliters over 125 milligrams times 1,000 milligrams over a gram times 0.375 grams over 6 hours. Is that how you would have done it?
You don't need to account for the time. The time is just part of how often you're giving the dose. So since you're only calculating per dose, you don't need to worry about the 6 hours.
Okay, because it'd be by default 6 hours. Okay, so it's just because one dose. All right, thank you. So other than that, I just take out 6 hours. Everything cancels out except for the milliliters, and so I do the math. 5 times 1,000 times 0.375 divided by 125, and I get the answer.
Correct. What do you get?
I didn't do it.
I know. I know what the answer is. I just want to make sure that your math works out.
All right, I got 15.
You got it. That's what I got too.
Thanks.
You're welcome. Yeah, and on questions like that, don't forget to mark your cup.
Yeah, that's a good point.
That's usually like a lot of people don't miss the math. They skip the step of skip the step of marking the cup.
Okay, question 12. Heparin, 4,000 units, SC is ordered. And so it wants to know how many mLs to give using the information on the tube. So I come up with you need 0.4 mLs. And so is that wrong?
I was just gonna say that's correct.
Oh, okay. So would I circle the one mark right before the half milliliter marker?
Correct. So, because 1/2 is 0.5, right? So this is where this would be your 0.4. Sorry, that's not straight. But yeah, or you'd circle it, but that would be your 0.4. You are correct.
Thank you.
You're welcome.
Drop. I don't remember whether you drop regular insulin first or the NPH insulin first.
You always draw regular first. So they always say clear before cloudy is like the, I guess, the mnemonic to remember, or the memory tool to remember. But regular insulin is always drawn up first.
Okay, so it would be syringe B, and the first draw would be up to the 10 mark, and the second draw would be up to the 50 mark.
So there's a little bit of nuance with this. So what is actually happening is, so when you draw this, you draw 10 units first, and then you draw the 40 units second. So you're actually going to mark the syringe in two different ways. You're going to mark at the total. Okay. So mark at the total for 50. So that's your total. That's also why I wrote these here, like in my answers. I want to make sure that whomever's grading this knows that I know what I'm talking about, because you're actually going to, your regular insulin, because it was drawn up first, is going to be closer to the total mark. So your regular insulin is actually in between these 2 points, is the hypothetical existence of where the regular insulin is. Now, I don't know if you've done this like in clinicals yet, or practiced the drawing of this, procedure, but all of it mixes together. There's no like separation, but the way they want you to mark it is how I'm showing you here, where the NPH is actually going to be the 40 units still, but it's down here, is how they essentially want you to mark it. So the two arrows that they want is one at 50 and one at 40, with the distance between the 40 and the 50 being the 10 units, indicating the regular insulin.
Okay, honestly, I don't think we did the one syringe method. We did the 2 syringe method so far.
Okay. And like I said, I've been I mean, not technically, I've been hoping that they would like just get rid of this question, because I just feel like it's not a good math question. It's a good procedural question, but it's something I think you could demonstrate in a clinical practicum, as opposed to, trying to mark things on a syringe. But if you go to the OneDrive folder, the very, like, before you go into any of the subfolders, you'll see something called like mixing insulin syringe, or mixing insulin. And there, I took a picture from a textbook that demonstrates how they want you to answer it.
That's how I wrote that down. OneDrive folder, mixing syringes.
Mm-hmm.